All right, so let's get the next tool in our toolbox, and that's going to be solving a system of equations using elimination. So I would like you to attempt this problem using the techniques of elimination that you learned back in Algebra 1, that you reviewed in Algebra 2, and reviewed in geometry. So try this one right now. So if I were to solve by elimination, what is the very first thing that I have to do? Strategery is what it says. What's the very first thing in order to do elimination, or in order to utilize this tool?
Do you get one variable for this? I mean, to cancel out, so then you just have one variable left.
That's we got to do something before that. You better remember. Most of you did it on your paper. You probably just did it without even thinking about it. The very first thing that I have to do is I have to get my equations lined up vertically. Meaning I want a column with all of my x's, or both of my x's. I want my x's on top of x's in the original form. And then I want y's on top of y's. Equal signs on top of equal signs. And numbers on top of numbers. Okay? So if we go back to this warm-up problem here, the very first thing that we would do is we would rewrite this equation to be 8x plus 2y equals 4 and negative 2x plus 3y equals 13. So I have to get them lined up vertically. I don't want them lined up horizontally. I want them lined up vertically. Okay? Now, step number 2. What do you think we would do next, Sam?
One of the variables to cancel out.
Now we're going to manipulate one or both of our equations. Oops. Wrong way. This way. Now we're going to we're going to manipulate one or both of our equations so that we have the same number in front of one of the variables, one positive, one negative. Okay? So I want to multiply either one equation or both equations or something along those lines. I want the numbers and the coefficients of x or the coefficients of y to be the same, just one positive, one negative. So in this case, a lot of you did this equation, this whole equation, multiplied by 4. Because if I do that, my top equation stays 8x plus 2y equals 4. And my bottom equation now becomes negative 8x plus 12y equals 52. And I have here and here, I've got a positive 8 in one and a negative 8 in the other. Okay? I could have also multiplied the top equation by 3 and the bottom equation by negative 2. We eliminate the y's. So then I would have had a positive 6y on the top equation and a negative 6y on the bottom equation. Okay? So that's what we mean by manipulating those equations. Next, what we're going to do is we are going to add the two equations together. When I add the two equations together, one of the variables should drop out. And in this case, it's the x's. 8x plus negative 8x is 0x, which is just 0. I've eliminated, hence the title, I've eliminated the x's. I get 14y because 2y plus 12y is 14y. 4 plus 52 is 56. If you add your two equations together and you still have two variables, you've done something wrong. Okay? Okay. Next step. Step number 4 says, now you're going to solve that remaining equation by dividing. It should be a single step solve to divide, and in this case we're going to divide both sides by 14. Giving me y equals 56 divided by 14? 4. Now what do you think we're going to do?
Plug the y into the original equation.
Okay.
Solve for x.
Next, we're going to substitute that answer that we got out of number 4 into one of the two original equations to get the other variable. So in this case, we're going to plug in y equals 4 into one of my two original equations. Left or right? Left. Okay. So then that would be 8x plus 2 times 4 equals 4. 2 times 4 is 8. Subtract 8. 8x equals negative 4. Divide both sides by 8. X equals negative 1/2. Okay? Now what should we do? Now we should check it back into our original equations. Okay? And that is, in fact, what the last step down here is. Check our work, okay? And then write our answer in the form of a point. Okay? So if I go back here and I say, all right, well, I've got x is negative 1/2 and y is 4, so that would be 8 times negative 1/2 is plus 2 times 4. 8 times negative 1/2 is negative 4. 2 times 4 is 8. Negative 4 plus 8 is positive 4. 4 is equal to 4. Checks out in the first one. Negative 2 times negative 1/2 plus 3 times 4. Negative 2 times negative 1/2 is positive 1 plus 12 is 13, and 13 is equal to 13. So it works out in both equations. I should check them each and every time. Before I circle my answer. That way I know if I'm right away. Okay? Questions on that one? Using those newfound steps and that newfound technique, or that remembered technique, solve this system of equation using elimination. First step is already done for us. It's already lined up. We just got to kind of pick which one we want to or which variable we want to eliminate. If I want to eliminate x, I'm going to multiply the top equation by 4 and the bottom equation by 3. If I want to eliminate y, I'm going to multiply the top equation by 7 and the bottom equation by 6. Okay? So my guess is the majority of you chose the first option, a little smaller numbers, so I'm going to multiply that one by 4 and this one by 3. That gives me 12x minus 24y equals 36, and negative 12x plus 21y equals negative 48. From there, then, we can add those two equations together. When I add them, my x's have been eliminated, and I get negative 3y equals negative 12. Solving that one gives me y. Oops, tap the brakes, got a little extra in there. Solving that one gets me y equals positive 4. Then I stick that into one of the original equations. 3x minus 6 times positive 4 is equal to 9. X minus 24 is equal to 9. 3x is equal to 33. X is equal to 11. Three times 11 is 33. Minus 6 times 4 is 24. 33 minus 24 is 9. 9 is equal to 9. Negative 4 times 11 is negative 44. 7 times 4 is 28. Negative 44 plus 28 is negative 16. Works out, checks out, so my answer then is 11, 4. Questions on that one? Yes, ma'am.
Are these just different ways to solve like the same equations, or do you have to use one for like a specific?
Right now, we're getting tools into our toolbox.
Okay.
Okay.
But like, could you use substitution and elimination on the exact same? Okay.
Yep. Elimination is a little easier because we don't have to solve one for one variable. Like in this particular case, it might not be the easiest to solve for a variable. Okay, because we're going to get it. Well, actually, we could solve the top equation for x because they're all multiples of 3. But you know what I mean? This way it gets around that fact of, oh, we can't solve every equation for a variable. Yep. Yep. Try this one using elimination. First thing on the first equation, I would move the negative 3x from the right side to the left side. And on the second equation, I'd move the positive 10y from the right side to the left side. I could multiply the top equation by 5 and the bottom equation by 2. That would eliminate my y's. Or I could multiply the bottom equation by negative 3. That would give me 3x plus 4y equals positive 1. And I have to multiply by negative 3 so that I get negative 3x there.
Shouldn't that be a 6 instead of 1?
Oh, yes. Good job, Aaron. Okay. Plus 30y equals negative 18 there. Okay. Now I can add the equations because I have same coefficients, just in opposite form. That gives me 34y equals negative 17. Divide both sides by 34, I should say. Gives me y equals negative 1/2. If I have y equals negative 1/2, I'm going to put it into my second original equation. Negative 1/2 times 10 is negative 5, so I get x equals 1 there. Checking it back, 4 times negative 1/2 is negative 2. 1 minus 3 times 1 is 1 minus 3, which is negative 2. Checks out in the first one. 1, 6 plus 10 times negative 1/2. 10 times negative 1/2 is negative 5. 6 plus negative 5 is 1. Oops, that should be an equal sign there. So my answer here is 1, comma, negative 1/2. Questions on that? Again, check your work. You should know at the end of every problem whether or not you got to go back and fix something. Okay? On these two, remember I told you way back a while ago now, because we've been gone for so long, that we had two special situations. We have three possible answers in all of these. We can either have a point, which we just did 3 examples of where it met at a point. We could have no solutions, or we could have infinite solutions. Okay? So if I take this top equation and I multiply it by 2, then that gives me 6x minus 12y equals 28. And I add to it the second equation. Following my steps, the x's go away. What about the y's? They also cancel out. So that leaves me with 0 on the left side. I got nothing. Everything canceled out. And then that is equal to 12 over here. So after you go through your elimination and you get a false statement, with no variables, just like in substitution, we will call that no solution. Okay. So that's a no solution case if you get a false statement with no variables. So if you have 0 equals some number, really is the only false statement that you would get in an elimination case. When everything cancels out and you get 0 equals 0, so that is the only true statement, So the true statement that you would get would be 0 equals 0 with no variables. That then becomes our infinite solutions. Yes, ma'am. It will be 0 equals 0 because your both x and y will cancel out. And you'll have everything lined up, so you won't have numbers on that left side. You would have only variable terms on the left side, and both of them would cancel out. So it's going to be 0 equals some number or 0 equals 0. That are your only two options there. Okay? Just to refresh yourselves with this slide, you already have it in your notes. It was on, we took down the exact same slide in substitution. Okay? So if the variables cancel out and it's a true sentence or a true statement, that's an infinite solutions case. If the variables cancel out and it's a false statement or sentence, no solutions case. If the variables don't cancel, then that is going to result in a point. Okay? And again, those are your three options. Infinite solutions, no solutions, or a point that they intersect. Okay? Last example that I would like to talk about today is I want to refresh ourselves with word problems, because it seemed to me that we were having some issues the other day with the word problem that I gave you in the first half of this homework. Okay? The very first thing that you have to do in a word problem is you have to read it. Okay? So before you write anything down, make sure you read it once or twice. $2,384 in revenue was made from 378 adult passes and 214 children passes sold to the county fair. An adult pass costs $2 more than a children's pass. Find the cost of an adult and children's pass. Okay? So the very first thing that you have to do is you should read it. We did that. The very next thing that you should do, and we had a problem very similar to this with guitars, acoustic and electric guitars the other day. The very next thing you should do is you should define your variables. Okay? I was helping a few people, some via text message, some via pop-in. Okay? They were asking me, well, are these the equations? And the first question, because they were in x's and y's. I said, well, what's x and what's y? And they couldn't answer me. And I said, well, that's the whole point. You need to know what variables are what. In this case, sure, I could use x and I could use y, but I would rather use A for adult passes or the cost of an adult pass, and C for a child's cost. Relate it to the problem. Sure, I could have used X as the cost of an adult, Y as the cost of a child, or vice versa. But relate it back to it. Okay? So I need to see that definition of your variable so that you know what you're talking about. Okay? Second, or third thing now we have to go back and we have to reread the problem and make two equations. For every variable that you define, that's an equation that you have to make. We just defined two variables. I got to make now two equations. Okay? So A is the cost of the adult, C is the cost for a child. $2,384 in revenue was made from 378 adult passes and 214 children's passes sold. So to me that says 2,384 is equal to 378 adult passes and 214 children's passes. Number of tickets sold times the cost per ticket gets you how much money you brought in. So we brought in $2,384. We sold that many passes. So there we go. Okay. Next sentence says, an adult pass costs $2 more than a child's pass. Okay. Now, we've created two equations. We've got two variables. We need to solve for those two variables. So, what we need to do is we need to figure out which tool we're going to use in our toolbox. Right now, we have three of them. We've got graphing, substitution, and elimination. Okay? If the directions to the problem specifically say you need to do it a certain way, then you need to do it that way. If the directions just say solve, you get to pick. Okay? Now, let's be honest. Graphing is probably the one that you are least going to pick. I get it. I rarely use graphing to solve anything. Okay? Substitution, if it's set up for you, yeah. This one, yes, it is set up for you. Okay? You've got A equals something already. You can just plug that back into your other equation. Okay? Or you could use elimination. Okay? So since we're talking about elimination today, I'm going to solve this one using elimination. So the very first thing that I'm going to do is I'm going to get them all lined up. So 378A plus 214C equals 2384. And then over here, this one is really A minus C equals 2. And I'm going to multiply that by negative 214. Oops, excuse me, no, positive 214. The C is already negative. So that gives me 214A minus 214C equals 428. Add those two equations together. My C's now are eliminated. 592, 2000, let's go 2 out there, carry the 1, 1, carry the 1, 2812. Divide both sides by 592. Ooh, I'm going to need some help on this one. Somebody with a calculator. 2812 divided by 592. 475, because we're talking money here now. So we're talking. Yep. So we're talking, because if we were talking regular, then we'd keep it in fraction form. But because we're talking money, we're going to put it in decimal form. So that is what our suspected adult cost is. What then would be our child cost? Because it costs $2 more for an adult. We can do that one in our head. Okay. So now we should check it. Okay. Adult costing $2 more than a child? Yep, checked. 2384. So let's go, what is 378 times 4.75? And what is 214 times 2.75? Those numbers, please.
For the kids, it's 588.5.
Adults, 378 times 4.75, bless you.
1,795.5.
What was it?
1,795.
Okay, so if I add those two together, 2384, isn't it? Yep, 2384. Now, one of the side benefits of defining your variables is, in this case, we are not looking for a point. I'm looking for the cost of an adult ticket and the cost of a child's ticket. So if I define my variables and I leave a little extra space next to it, there is my answer. I don't have to rewrite it. Okay? Had you rewritten it and you just said 475 and 275, you would be wrong because I don't know which one you're talking about. Okay? So you need to define, when you give your answer on these word problems, your answer is going to be specific in terms of what you are telling me is how many of something. Okay? So, a couple of homework problems tonight, due on Monday when we get to class. Again, you will have a formative next week, Tuesday, in the Resource Center, and a quiz for sure on the 7th, which is next week, Thursday. So formative Tuesday, quiz Thursday.